Hello dear friends, welcome my channels. Today's discussions is group theory plus linear algebra questions. So friends, first questions. Let A be a 7 cross 7 matrix such that 2a square minus a to the power 4 equals to 1. 2a square minus a to the power 4 equals to 1. This is annihilating polynomial. This polynomial is called annihilating polynomial. If A has two distinct eigenvalues and each eigenvalue has geometric multiplicity 3, then the total number of non-zero entries in the Jordan canonical form of A equals means how many non-zero entries in Jordan canonical block of A. So friends, it is given annihilating polynomial is 2 square minus a to the power 4. So plus 1. So it can be written a to the power 4 minus 2 square plus 1 equals to 0. And it can be the polynomial can be written x square minus 1 whole square equals to 0. Otherwise, it can be that implies x plus x minus 1 whole square and x plus 1 whole square. Friends, I don't know what is minimal polynomial. Annihilating polynomial is given, but minimal polynomial is not given. So 7 cross 7 is the matrix. My total eigenvalue 7 total 7 cross 7 7 cross 7 as 7 cross 7 is as the matrix order, so total eigenvalue must be 7. So my minimal polynomial is divided by annihilating polynomial. So my minimal polynomial dividing this polynomial x minus 1 whole square and x plus 1 whole square. So two distinct eigenvalue. Also it is given that two distinct eigenvalue. A has two distinct eigenvalues. So two distinct eigenvalues 1 and minus 1. Okay, you get two distinct eigenvalues, that one is 1 and minus 1. Another factor, friends, each eigenvalues has geometry multiplicity 3. So my geometric multiplicity is also GM of 1, GM of 1 means 3, and GM of minus 1 is 3. 3 means geometric multiplicity 3 means 3 linearly independent eigenvector. And here also 3 linear independent eigenvector. So friends, 3 linearly independent eigenvector means a row into a minus row x equals to 0. A minus row x, sorry, a minus simple ix equal to 0. So I get 3 solutions, and a plus ix equals to 0, I get also 3 solutions. You must remember this is the another logic. This logic should be remembered. Greater than equals to gm. am greater than equals to gm. So my possibility. So my possible eigenvalues, you will see that, friends. What is my possible eigenvalues? Because already geometry multiplicity already given, so 3 3 3 3 3, and my eigenvectors are 1 and -1. So friends, whatever we get 1 1 1 -1 -1 -1. This 3 is always, we get always 3. This 3 eigenvalue I will get, but my another eigenvalue is maybe 1. In case first case I get 1 and number B. Second case I can get 1 1 1 and -1 -1 -1 -1. This is the possibility, friends. How this is the possibility? Because friends, you see whatever you see, friends, you see that 3 is geometric multiplicity. So my algebraic multiplicity always equals to of the geometric multiplicity. Otherwise it is greater than geometric multiplicity. And as my dimension is 7, so you can, if you count, then my dimension is 7, and only 2 distinct eigenvalues. 2 distinct eigenvalues are 1 and -1, friends. Otherwise any others eigenvalues you cannot get from this matrix. So my JCF, now I will discuss JCF. So JCF, first case, first and second both case, my possibility will be 1 1 0 0. This is one case possibility, and 1 1 -1 -1 -1. So 1 2 3 4 5 6. 1 2 3 4 5 6 7. Yeah, okay. My possibility is this is one possibility, friends. This possibility can be hold, because 7 cross 7 matrix I will get JC. So my non-entries are 1 2 3 4 5 6 7 8. 8 is my possibility. If I will my JC block, is another possibility is -1 1 0 -1 and -1 -1 1 1. This is my total. Another possibility. Here you also get 1 2 3 4 5 6 7 8. Here you also get 1 2 3 4 5 6 7 8. So here you also can get 8. And you have to remember this theory, that number of Jordan block corresponding eigenvector lambda, equals to gm of lambda, corresponding eigenvector of gm of lambda. So friends, you will see that in case of 1, gm is 3, so my number of Jordan block is 3, and minus 1, the number of Jordan block is 3, and here also you can get 3 and you can get also 3. This is the main reason that why is gm of lambda, why it is 3. So friends, my answer is 8. Next question, this is the GATE 2017. Next question also GATE 2017. If u and v are null space, then 1 1 0 0 and 0 0 1 1 2 3 2 0 0 respectively, then the dimension of subspace u plus v equals to. So I have to find out dimension of u plus v. So at first I write the rank nullity theorem. So friends, if u and v are the null space of these respectively, then the dimension of subspace u plus v equals to. At first I have to find out dimension, and let u is equal to x1, x2, x3 and 1 1 0 0 and 0 0 1 1, x1, x2, x3 equals to, and x4 also. In here you get x4. So this is x4 equals to x1 plus x2 equals to 0 and equals to 0. So friends, x1 plus x2 equals to 0 and x3 plus x4 equals to 0. So number of Li is equal to whatever you get, number of Li, number of linearly independent equation is 2. So dimension of u equals to whatever you get, dimension of u is equal to n. Here n is equal to 4, means number of column. In this matrix is 2 cross 4 matrix. 2 cross 4 matrix, 4 is column. So 4 minus Li, number of Li solutions. So number of Li solution is equal to 2. So 4 minus 2. Similarly, we can get dimension of V is equal to 4 minus 2 equals to 2. So 4 minus 2 equals to 2. So dimension, now I have to find our formula. Dimension of u plus v equals to dimension u plus dimension v minus dimension u intersection v. So dimension of u plus v, dimension of u plus dimension of v, u minus dimension u intersection v. So friends, I have to find out dimension u intersection v. How can I find out? So friends, let x comma y comma z, if x comma y comma z comma w belongs to u intersection v, then x y z comma w belongs to u, and x comma y comma z comma w belongs to v. And now you see that x plus y, whatever you see x plus y equals to 0, and x and z plus w equals to 0. X plus z plus w is equal to 0. So x is equal to minus y and z equals to minus w. Another factor, friends, whatever you can get x plus 2y plus 2z plus 2w equals to 0, and y plus 2z plus 2w, w is equal to 0, and from this x and minus y and z minus w, we can get only one equation, y minus w equals to 0. So our valuation, our eigenvector is y equals to w. So I can write x is equal to minus w and z equals to minus w, and minus w minus w and w, and my vector is w if you take common, so it is minus 1 1 minus 1 1, and I get only one vectors. So my here eigenvectors is 1. So how can I solve these questions? This question is very simple. This question is, answer is 2 plus 2 minus 1 equals to 3. So this way I find out the dimension u plus v, the dimension of uv. Another way is that whatever is factor, friends, you will just write a matrix and find out free variables. So what is my matrix? Matrix is 1 1 0 0 0 0 1 1 and 1 2 3 2 and 1 2 1 0 1 2 1. This is your matrix, and after that row and column operations, whatever you get, you can get everywhere entries operations. So I get this type of echelon matrix, and 0 0 0, this is my one free variable, so that's why it is 1. This way you can find out the intersection of matrix. Now let's go to solve another problem. This problem is coming from csir net 2019. Consider the vector space Pn. Consider the vector space Pn of real polynomials in X of degree less than or equal to n, define T such that P2 tends to P3, T f x equals to 0 to x ft dt f dash x. Then the representations of T with respect to the basis, this is. So friends, my basis is given. So at first I have to find out T f x is equal to 0 to x ft dt plus f dash so friends, whatever you see the basis vector is 1. This is my T. So first is case fx. So my domain portion is this is my domain and this is my codomain. Notice that my domain is this and my codomain is this. So first is T of 1. T of 1, so 0 to 1, if T is 1 and dt and derivative is 0, so my value is T. It can be written, it can be represented this way, is equal to 0 into 1 plus T plus 0 into T square plus 0 into T cube, 0 to x. So it can be written this way, x square and x cube. This is the way. And after that I can write T of x. So 0 to x. So friends, this formula is T dt is equal to, it is x square by 2 plus 0 x cube, and similarly T of x square is equal to, can be written 0 to 2 x is equal to T square dt plus derivative of T is equal to 2t, so it is 2t, 2x, it is 2x. So it can be written this way, 0 into 1 plus 2 into x plus x cube by 3, sorry, it can be written 0 into x square plus x cube, and T can be written, my T can be written this way, because row will be column will be row, so it can be written this way, 0 1 1 0 0. First is 0 1 0 0, another is 1 0 x square, sorry, not x square, it is half, 1 0 half 0, another is 0 2 0 1 by 3. This is my matrix, transformation matrix. And after that, whatever I have to find out, define T such that consider the vector, then the representations. So my matrix representations is this. I find out my matrix representations. This is my matrix representations. I hope I can clear this concept. Next problem is PAX denote the characteristic polynomials of a matrix A, and then if or which of the matrix PA is equal to PA inverse is constant. So friends, which answer, now we start giving answer. A is equal to, let A is equal to A, B, C, D, and PAX is equal to determinant of xi minus a, and it can be written this way, that date, because it is already tell the characteristic polynomial can be written this way. It is my given characteristic polynomial is given, so give a characteristic polynomial of a is equal to date of xi minus a. So the value is x minus a minus b minus c into x minus d, and this value is x square minus a plus d into x plus ad minus bc, and this value is x square minus trace of a plus date a. Another factor is PA inverse. A inverse is equal to date D PA inverse x equals to date xi minus A inverse equals to x square minus trace of A inverse x plus date A inverse. So PAX minus PA inverse x is equal to trace of A inverse minus trace of A into x plus date of A inverse minus date of A. So friends, whatever you see, this is also 0 and this is also 0. So friends, whatever you see, that trace of A inverse equals to trace of A inverse equals to trace of A. So date of trace of A inverse, trace of A, when D plus A equals to date of A equals to D plus A, so date of A equals to 1. So date of A equals to 1. So I have to check where determinant of A equals to 1. In first option is 3 into 4, 12, and 3 to the 6. So this option is also wrong, because as date of A not equals to 1. Number 2, this option also wrong, because at date of A not equals to this option is correct. This option and date of A equals to 1, and this option is also wrong, because date of A is equal to -1. So option 3 is correct. Nice question friends, because you see that trace of A inverse is equal to trace of A inverse is equal to D plus A is equal to date of A. Remember this friends, and you will see trace of A is equal to trace of A plus D. So I just comparing these two facts, that D plus A divided by date A is equal to D plus A, as trace of A inverse is equal to trace of A. So date A equals to 1. Which of the following matrices is not diagonalizable? This is the matrix and this is the matrix. This is the matrix. I have to check. Important results friends. Eigenvalues of upper lower triangle matrix are diagonal. Number one case, if the algebraic and geometric multiplicity of each eigenvalues are equal, then it is diagonal algebraic matrix. Geometric multiplicity is less than equals to algebraic multiplicity, friends. I have already told. And if algebraic multiplicity is 1, then the geometric multiplicity is also 1. And if matrix has distinct eigenvalues, then it is diagonal algebraic. What is algebraic multiplicity? Algebraic multiplicity is the algebraic multiplicity of an eigenvalue lambda is a number of occurrence of lambda as a root of characteristic polynomial. Geometric multiplicity, the geometric multiplicity of an eigenvalue lambda is the number of independent eigenvectors associated with an eigenvalue lambda. So friends, I start first matrix. My first matrix is 2 0 0 0 3 0 1 0 2. This is my first matrix, friends, and this matrix I say this is A. So you see that upper lower triangle matrix are diagonal and eigenvalues of upper lower triangles are diagonal. So friends, here you can see that 2 3 and 2, this matrix are upper triangular matrix, and this is the eigenvalue are eigenvalues are 2 3 2. Eigenvalues are 2 3 2. So friends, now let's check that algebraic multiplicity and geometric multiplicity. So friends, algebraic multiplicity, because 3 is 1, so I don't need, because geometric multiplicity gm and am of the 3 is 1, but I have to check algebraic multiplicity and geometric multiplicity of 2. Multiplicity of 2 equals to 2, and geometric multiplicity I have to find out. Of 2 I have to find out. How can I find out, friends? Very simple. A minus, at first I have to find out a minus 2i. So a minus 2i into a minus 2i rank of a minus 2i. So how can I find out the rank? Now let's see, 0 0 1 0 1 0 0 0 0. So friends, we get this rank is 2. So rank of the a minus 2i is equal to 2, and gm is geometric multiplicity formula. gm of 2 is equal to n, dimensional n. N means column is 4. This is a 3 cross 3 matrix, so 3 minus 2 equals to 1, so we get 1. So m does not equals to gm. This reason this matrix is not diagonalizable. So my question is, which of the following matrix is not diagonalizable? So first option I got, first option is correct. My first option is correct. And second option is J matrix. The matrix is J matrix 1 1 1. So it is J matrix. J matrix eigenvalue obviously 0 and 2. So this value is diagonalizable. This value I have to check number 3. In case of number 3, whatever you see, in case if we choose the number 3, we need to know, because the question is C section, only one option is correct. So first option is correct, but 3 I have to check. Number 3. So whatever my here I get eigenvalue 2 1, right? 2 1 3 3 0 0 0 0 0. So eigenvalue is 2 3 3. So I don't need to check 2 because AM is GM 2, but 3 in case of 3. So whatever I get 2 1 0 0 0 0 0 0 0. This is my a minus 3i, and a minus 3i rank of a minus 3i equal to 1. So whatever I get GM equals to 3 minus 1 equals to 2 and equals to AM. So it is diagonalizable. This matrix is also diagonalizable. This matrix is also diagonalizable, and this matrix, now if you see this matrix eigenvalue is 3, one eigenvalue, another eigenvalue is 2. So all are distinct, so it is also diagonalizable. D for diagonalizable, this is diagonalizable, and this is not diagonalizable, ND. So I think I can clear this concept. And number 6. Number 6 is the vector space of the real value of the axis, and the W be the subspace of the span sin x, cos x, tan x. Then the dimension of over R is 1 2 3. So friends, how can I find out dimensions? So friends, what is the meaning of the dimension? Dimensions are the basis, number of the basis. What is the meaning? So let's start. f2x, f3x. This is the total set. So the function of the set, and wx equals to, what is the wx value, friends? Wx value is f1x, f2x, f3x, f1 dash x, f2 dash x, and f3 dash x, f1 double dash x, f2 double dash x, f3 double dash x. This is my Wronskian. Now Wronskian is equal to this, and Wronskian value, and this value is equals to, I can write this way, sin x, cos x, tan x, derivative cos x minus sin x, sec square x. Integration differentiation of tan x is equal to sec square x, and cos x derivative is minus sin x minus cos x 2 into sec x into tan x. This is the total formula. And now this formula, if I will find out the determinant value is tan x minus tan x into 2 tan x plus 3, and this value, if w is equal to pi by 4, Wronskian does not equals to 0. Wronskian is equal to 5. Wronskian is equal to 5. So dimension of w. So the process, the main factor is, if Wronskian does not equals to 0, this means linearly independent. Linearly independent, and this 3 sin x, cos x, and tan x are linearly independent and spanned. So the subspace is spanned by the, so whatever my dimension of the vector space is 3. Now friends, we are discussing another problem. Let M equals to A, B, C, B, D, E, C, E, F be a real matrix. The eigenvalue, what is the given? I mark, at first I will mark 1, 0 and 3. And the eigenvectors of corresponding 1 and 0 are 1, 1, 2, this is my given for I, and 0, this is the given for this. So lambda 1 eigenvalue, I have to write all the question 1 1 1, and lambda 0 is equal to 1 minus 1 0. All are eigenvector e lambda 0, e lambda 1. This is the proper way. Now I have to find out 3f is equals to what. So you will see that, friends, ADF is the trace of the matrix. Trace of the matrix. So the formula, what is the characteristic equation formula? Characteristic equation formula is x cube minus trace of a x square plus a1 1 plus a1 2 plus a3 3 a2 2 cofactor of the a2 2 a1 1. This is the process, and plus minus date a matrix. Let a or you can say it is m11 because it is already given, m11 m22 m equals to a b c, sorry, a d f b c e b c e. So friends, this is my matrix process. And how can I get? I can get x cube minus trace of m equal to a plus d plus f x square. Okay, trace means total additions, diagonal, sum of the diagonal, we know already. And m11 m22 and m33 is equal to, can be written this way, df minus e square, and m11 m22 is af minus e square and minus e square, minus c square, sorry, not e square, minus c square, and m33 equals to ad minus b square. How can I find out? I just cross this, then you can get ad minus b square if t is process. So you can get c square af minus c square. This is the x, and determinant of m, date m equals to date m equals to 0, because as eigenvalue equals to 0, so date m equals to 0. So this is date m value is 0. So this is my total formula, friends. And now how can I find out? As lambda is 1 and another is 0 is my lambda value. So eigenvalues formula is, if we consider eigenvalue, what is given? So a b c and b d e and c e f into eigenvector is 1 minus 1 and 0 in the case of 0. Case of 0 eigenvectors EV. So whatever I get a equals to 0. So a plus b plus c equals to 0. This is I get, and b plus d plus e equals to 0. These two value I get from where I get these two value I get from here. So a plus b equals to 0. Sorry, it is not correct. Which equations I get? I write a minus b equals to 0 and b minus d equals to 0. A minus d equals to 0. So whatever I get a equals to b equals to d. This is one conditions I get. Another conditions, friends. Another conditions is a minus 1 b c and b and b minus 1 e and c e into f minus 1, because a minus lambda a minus I into x equals to 0. So x is in here, x is for x is 0. For 1, what is my 1 so for this is, so I multiply 1 for 1 case 1. So whatever I get equals to 0. So I get a minus 1 plus b plus c equals to 0. So a plus b plus c equals to 0. C 0. A plus b plus c is equal to 0. B plus d plus e equals to 0, and c plus e plus f equals to 1. Everywhere is 1. It is not 0, 1. So this is 3 equations I get. And now I have to solve these equations. How can I solve these equations, friends? I know a equals to b equals to d from these equations, and another equation, another way I can get so a plus b plus c equals to 1. This I get, and b plus d plus e equals to 1. Another case, friends, you will see that eigenvalue are 1, 0 and 3. So trace a plus d plus f. A plus d plus f is equal to 4. This is another case. So I get a plus d plus f equals to 4. This value I have already get. I get. So whatever so how can I solve this? And I have to solve these equations. B plus d plus e is equal to 1. C plus e plus f equals to 1. Another is multiplication, says I have to c is equal to c minus e. C minus e is also 0. So I get c equals to e. This is another point. So I get c equals to e. C equals to e. A equals to b equals to d. So from 3, this equation, now I am putting this equation that 2a plus f is equal to 4. because A is equal to D. These equations, A equals to D, so 2A, as A equals to D, so 2A equals to 4F, and 2C plus F equals to 1, as C equals to 1. E equals to C equals to E, so I can write 2C plus F equals to 1 and added this portion, so I can get 2A plus 2C plus 2F equals to 5. So equals to 5. Okay, I multiply with 3. I multiply with 2. This is good way. So I can get in here 9. I can get in here 9, and here I can get F, here I can get 3F. 4A plus 2C is equal to 3F. So 3F is equal to 9 minus 4A minus 2C. 4A minus 2C. And now 4A minus 2C. Now whatever we see that A plus B plus C is equal to 1. So 2A plus C is equal to 1. So 4A plus 2C equals to 2. So 9 minus 2 is equal to 7. So according to the question, whatever they ask, they are asking 3F is equal to 7. 3A is equal to 7. Now let's solve GATE 2011. Now I am going to discuss group theory. So L equals to, whatever I get, L equals to R mod X divided by X square minus X plus 1 L, and M equals to R box X square plus X plus 1. This is the total 2 L and M. If you see, whatever you see they are irreducible. X square minus X plus 1 and X square plus X plus 1 are irreducible over R. Irreducible over R. So L is isomorphic to M. L is isomorphic to M. Another factor, whatever this, another factor is X square plus 2X plus 1 equals to X plus 1 whole square, which is reducible over capital R. So N is not isomorphic. N is not isomorphic. Morphic to M on L. So my which option is correct? L is isomorphic to L is isomorphic to M. Correct. L is isomorphic to M. and L is not isomorphic to n, M is not isomorphic to n. So option A is correct, and M is isomorphic to n. This is not correct. Other options are not correct. Now I am going to solve another questions. GATE 2010. G be an abelian group of order 6 and G2 equals to is 3. So J equals to 1, 2 dot dot, and Pj be the statement. Pj be the statement. Pj be the statement, and Gj is a unique subgroup of order 2. So Pj, P1 and P2 are hold, P1 and P2 hold, that I have to check. So Gj is unique subgroup of order 2. Gj is unique subgroup of order 2. Let's see how can I, let's see. Order of G1, whatever it says, order of G1 is equal to 6. You will check order of G1 equals to abelian group, order of G1 is equal to 6. So 6 is equal to 2 into 3, and 2 does not divide, divisible by 3 minus 1. Therefore G1, because G1 is, because 2 divisible by 3 by 1, so by the theorem G1 is cyclic group conditions. G1 is cyclic group, and G1 has unique subgroup of order 2. Unique subgroup of order 2. It is already, it is told in the questions. Because corresponding to every divisor of the order of cyclic group, there must exist a unique subgroup. There must exist unique subgroup. So what is the formula? Every divisor of the order of a cyclic group, every divisor of the order of a cyclic group there must exist a unique subgroup. There exists a unique subgroup. So friends, P1 is correct. P1 hold. Now in case of P2, in case of P2 is in case of P2, then G2 equals to statement P2, G2 is equal to S3. So it is I 3, 2. S3 is very well known matrix, well known group. 1, 3. 3, 2, 1, 3, 1, 2, 3. and 1 3 2 and 1 2. Another is 1 2. Then we can get subgroup of the S3 is H1. H1 is I comma 1 2. H2 is I comma 1 3, and H3 is I comma 2 3. H3 a subgroup of H3 of order R, subgroup of order 2 in S3. So therefore G2 has 3 subgroup of order 2. So 3 subgroup of order 2. G2 has 3 subgroup of order 2. So which is not hold. That unique, what is my in the question, unique subgroup of order 2, this statement does not hold. Means unique subgroup of order 2, this does not hold. So P1 holds but P2 not. This is correct. Next problem is the consider the polynomial qx and the ideal of qx generated by x square minus 3, maximal but not prime ideal, prime but not maximal, both maximal and prime, and neither maximal not prime. So friends, you will see that x square minus 3 equals to 0. So x is equal to plus minus root over 3, which does not belongs to q. So this polynomial is irreducible polynomial, friends. Irreducible polynomial. So simple, friends, it is both maximal and prime, because we know that qx by x square minus 3 equals to f, because it is irreducible. Irreducible over q. Over q. So it is field. Field means it is maximal. This ideal is maximal, and every maximal ideal is equal to prime ideal. So converse is not true, however both maximal and prime ideal. We are going to solve next problem. Next problem is Eisenstein problem. Problem is the let Q be the field of rational numbers and consider Z2 as a field modulo 2, and fx is equal to x cube plus 9x square plus 9x plus 3. Then fx is the value. I have to find out the value. So whatever I get, my fx is equal to x cube minus 9x square plus 9x plus 3. This is my fx, and let p is equal to 3, and now 3 does not divisible by 1, this coefficient, and 3 divisible by 9, 3 divisible by minus 9, 3 divisible by 9, and 3 divisible by 3. This is the condition number 1. and condition number 2 is 3 square does not divisible by 3. So my two condition is hold. So fx is irreducible over irreducible over q. Fx is irreducible over q. This condition hold. And next condition is irreducible over q. And after that I have to check z2 is equal to 0, 1. You will see z2 is equal to 0, 1. And now I will putting the value 0 plus 0 plus 0 is equal to 3 is equal to when f0 then it is 1, and when f1 1 then it is also 1 minus 9 9 9 9 4 is then it is 4, and this is equals to 0. But as this is does not equals to 0, so it is not, it is irreducible. Reducible is x cube minus x square plus x plus 1. Then the value is 1 plus 1. It is does not equals to 4. I get 4 is does not equals to 0. So it is irreducible. 0 and 1 are not roots of fx, so it is also irreducible. So both q and z2. Next problem. Next problem is ideal generator. Generator is x to the power 4 plus x cube plus x square plus 1 and z2x, and z2x divided by I. Then the f is infinite field and f is finite field of f. Sorry, this is the modulo property, so it is also 0 mod mod 2 equals to 0, but it is irreducible as this portion f0 is not root, so it is irreducible, not reducible. All roots are not 0 are not root of fx, so it is irreducible. Another property is x to the power 4 plus x cube plus x square plus x plus 1. This is the ideal generator. This is the ideal. My ideal is, this is my ideal. I is my ideal. And z2 is, element of the z2 is 0 and 1. Element of z2 is 0 and 1, so f0 is equal to 1 does not equals to 0. f1 equals to 5 equals to mod of 2 is equal to 1. So five equals to 2 equals to equivalent to 1. So fx is irreducible over over z2x. Here is one of the questions that it is also 0. Here f1 is 0, but 0 are not roots of fx. 0 is not root of x, but 1 is also root of fx. So it is reducible or irreducible. Here it is clear that it is irreducible over z2x. So it is not irreducible, friends. Number A is correct, as irreducible over q but reducible over z2, because 1 is reducible over 1. If you see that 1 is root of fx. So z2 is here reducible over z2. So this is my answer. This is irreducible because no roots are in z2x. Irreducible. So irreducible, as irreducible, so it is prime ideal. Irreducible element means maximal ideal. So fx is maximal. Fx is maximal. That implies prime. So f value is z2x divided by root of the x to the power 4 plus x cube plus x square plus x plus 1. So field is 2 to the power 4 equals to 16. So f is finite field and 16 element. This is correct. Next problem is very interesting, friends. Next problem is let A equals to Aij be 10 cross 10 matrix such that Aij equals to 1, I does not equals to j, and Aij equals to alpha plus 1. Aij equals to alpha plus 1 when I equals to obviously j. So alpha is greater than 0, so lambda plus mu is equal to, so my matrix is A is equal to alpha plus 1 and another is 1 1 1, no problem, 1 1 1 and alpha plus 1, alpha plus 1, alpha plus 1. This is the 10 cross 10 matrix, friends, no problem. So A can be written this way: alpha 0 0 0, alpha 0 0 0, alpha alpha up to alpha 10 cross 10, and it can be another matrix is J matrix 1 1 1 1 1 up to 1 up to 1. So this is also 10 cross 10. This matrix is called J matrix, as both are commutative. So this is the commutative matrix, friends, because I can write A, it is A1, it is B1. So A1 plus B1 equals to B1 plus A1. So eigenvalue of A, in this case eigenvalue of A equals to eigenvalue of A1 plus B1. So eigenvalue of A equals to eigenvalue of A1 and B1. So eigenvalue of A equals to eigenvalue of A1 plus eigenvalue of B1. So what is the eigenvalue of this J matrix? J matrix, in case of J matrix, the property is, J matrix property is all the eigenvalue is 10, because all the n is means 10. 10 is eigenvalue, another is 0. 10 is eigenvalue. And characteristic equation CHX, characteristic equations of the J matrix is equal to x to the power n into x minus n. This is the characteristic equations, friends. So there are two matrix, one is 0, 0 and another is x to the power n minus 1 into x minus n. This is the two matrix, two kind of matrix, friends. So 10 and 0 are my eigenvalue, eigenvector. And in here my eigenvector is alpha. So friends, whatever I get the eigenvector of this A, eigenvector of A is equal to alpha and alpha plus 10. This is my least value. Obviously this is my lambda and mu is largest and smallest. This is my lambda and this is my mu. So lambda plus mu is equal to 24. So lambda is equal to alpha plus 10 and alpha is equal to 24. So 2 alpha is equal to 14. So alpha equals to 7. This is my answer. Alpha equals to 7. How alpha equals to 7, friends? Alpha equals to 7 because there are two matrix. One is alpha and alpha plus 10. J matrix is very important. And next problem, friends. Next problem is very statement type problem. Given two n cross n matrices A and B with entries in C, consider the following. A and B have same minimal polynomial, then A is similar to B. Now we are discussing the similar problem. A is equivalent to B. So eigenvector of A equals to eigenvalue based eigenvalue of A of B and JCF are equal. JCF of A equal to JCF of B. So in case of JCF, Jordan canonical block, minimal polynomial, order of minimal order of minimal polynomial is Jordan equals to block, order of JCF block. So friends, if you see that equals to, then minimal polynomial A lambda both are equal. Suppose 1 x minus 1 whole square is my mx. Both are A and B and x minus x plus 1 the minimal polynomial. So A is 5 cross 5 matrix A and B. A and B are 5 cross 5 matrix. So whatever you can get, I can write this way, that JCF is highest is this. So 1 0 1 0 is 1 1. This way I can write, and it can be 1 1 1 minus 1. and -1, say. So it can be written this way. 1, sorry, this is this way. It can be written this way and this way. This is the A, and B can be written, suppose same eigenvalue, 1 1 0 1 and 1 1 0 1 and -1. So my JCA block are not equal. Number of block is in here 4 and 4. So A and B is not similar. This option is false and this option is correct, because U is equal to a linearly independent, because as the characteristic equations a to the power n minus 1. So U is equal to, suppose U plus V plus I can get any number such that this way that these equations hold linearly independent. So only P is correct. Thanks for watching, friends.